Alrighty, here we are on lesson 11, describing distributions using the mean and the MAD. So we're talking more about that mean absolute deviation today, along with the mean and how we can use those to describe a set of data. So the opening exercise says, suppose that the weights of 7 middle school students' backpacks are given below. So if you look, all of the weights are the same, which means that the mean has to be 18. And that means that all of the deviations would be 0 then, so go ahead and fill those in. Which means the absolute deviations are also 0. Okay, so B says to draw a dot plot for the data and calculate the mean and the MAD. So we know that they're all going to go on 18, and I have 1, 2, 3, 4, 5, 6, 7 dots I'm going to put above the 18. 1, 2, 3, 4, 5, 6, and 7. And the mean we said has to be 18 because they're all the same number, which means that the MAD is 0. Alright, so you can write yourself a note here that says when the data points are the same, as the mean, MAD equals 0. Okay, so write that note there. Good to have. It'll save you some time. So this is kind of our initial problem that they gave us. Now problem 2 says, suppose that the weight of Alicia's backpack is 17 pounds rather than 18. So draw a dot plot for the new distribution. So that means we're going to have only 6 dots above the 18 now. 2, 3, 4, 5, 6, and we're going to have 1 above the 17. Alright, let's go ahead and flip the page in your notes. Part B says, without doing any calculation, how is the mean affected by the lighter weight? Would the new mean be the same, smaller, or larger? So if you think about it, we put a data point that's smaller than what we have, so we know the mean has to change now. So we would say that the mean would be slightly smaller. So just a bit smaller than the original one. Now it says without doing any calculation, how is the MAD affected by the lighter weight? Would the new MAD be the same, smaller, or larger? So remember our original MAD was 0, so we know it has to change, and we know it would have to be bigger than 0. So the new MAD is going to be bigger, or it's going to be larger, which means that you have more variability. Alright, now number 3 says, suppose that in addition to Alicia's backpack weight having changed from 18 to 17, Fred's backpack weight is changed from 18 to 19. So we're going to draw a new dot plot. So that means now we need a dot on 17 and a dot on 19, and now I only have 5 on 18. 2, 3, 4, 5. Without doing any calculation, what would be the value of the new mean compared to the original mean? Well, the mean, if we look at, would stay 18 because our data is balanced now. So we would say the mean will stay at 18 because 17 and 19 balance the data. So that's the difference between this example and what we did in number 2. C says without doing any calculation, would the MAD for the new distribution be the same, smaller, or larger than the original MAD? So the tricky part about this is the MAD will be larger And it can't be 0 anymore because not all of the deviations are 0. So it's not like the original one. So write that down to it cannot be 0 because not all deviations are 0. So you can see how the MAD acts a little differently than the mean does. Okay. So, example 1 says, suppose that 7 second graders' backpack weights are as below, so they're all 5. So A says, how is the distribution of backpack weights for the second graders similar to the original distribution for 6th graders in the opening exercise? Well, again, because they're all the same points, there is no MAD. So you can say that the MAD equals 0. But then part B says, how are the means different? Well, in number 1, remember the mean was 18, because all the data points were on 18. But in number 2 here, the mean would be only 5, because that's what all the data points are. Okay. So if you look at example 2 here, it says, Robert is trying to decide whether to move to New York City or San Francisco based on temperature. Comparing the center, spread, and shape for the two temperature distributions could help him decide. So they gave you the means and the MADs. Alright, I want you to think about these two, part A and part B, on your own. Alright, so make sure that you put something down so that we can discuss this in class tomorrow. So just go ahead and think about these two questions, have something written down to bring to discussion in class tomorrow.